people, so trainings and consulting and all of that sort of thing. And I'm sure all of you have heard the word Puppet a lot today, and a lot of people have been hearing Puppet Labs, and I'm just curious, how many people have actually heard of Puppet before today? Oh, okay, that's comforting actually. I was hearing a lot of questions before about what is this Puppet thing, what does it do? So how many of you are actually using Puppet or something like it? Much less. Okay, so hopefully you're all interested, because this I should sort of talk about the basics of this and how Puppet is set up. And particularly I want to talk about how this is especially relevant in the continuous delivery space, since this is a continuous delivery conference. And hopefully if we have some time, I'll do a little bit of a demo of some of the features of Puppet. So obviously, from everything that everybody's described to us so far, this continuous delivery thing really adds a lot of value to the business. You can react more quickly to market conditions. You come up with new ideas. It's much easier to test them out and to implement them. You can fix bugs much faster. So when something bad gets into production, you can get it out very quickly. You know, just this tighter feedback loop. Everything is faster, and as a developer, it's fantastic. As a business, it's fantastic. You have so much value that you can add so easily, and it's great. But once you've created that artifact, you're not finished with the process. You know, I'm sure that many of you have realized that I've heard a lot of expressions about frustrations with the IT group, and I was usually on that side of the equation. I know how it feels. It's tough to get that stuff out there. And just because you're finished with what you've deployed doesn't mean that it's actually running and adding business value. You can ship every 10 minutes a new version of your product, but it's not in front of users until it's on your infrastructure. So obviously this infrastructure is very important. Okay? It doesn't matter how fast you're going if your code's not running. So think about how long it takes to actually get this code, you know, this continuous delivery pipeline that's been built. It tends to shift so far, you know, we're getting these packages out, we're getting all of our work done, but how long does it take to go from the time the developer and the QA team says, okay, it's done, to actually being running? There was some mention before about huge packets of paper, you know, multi-tab documents that say these are the steps that you need to go through in order to actually deploy your artifact, that some ops team or some, you know, poor soul in India has to go through and actually run through the deployment on. You know, all of these things are really important. And you know, when you have issues in this, how can you recreate these issues? You've got this artifact, you've got this fantastic version control, you know exactly what your software is supposed to do. But when you have a problem in production, how do you know that the problem was caused by something you did or something that the operations team did? You know, how is it, you know, these differences between your environment and all of your QA and testing really matter a lot for this. So as an operations team, you know, you need to try to catch up with this speed. You know, the developers are pushing stuff at you so fast that you really need to get out there. Although your primary job is to keep everything up and running, keep the lights on. So you kind of get to pick between two things of, am I going to move fast? Is everything going to be stable? Or am I going to sleep tonight and this weekend? And this is how it is. How many people here are sysadmins or on the operations side of the picture? And you all know what I'm talking about. So in general, the operations industry has been way behind where this, you know, development practices have been. You know, you think about the term agile was coined in what, like 1995, something like that, or 2001 something. People have been doing this for a very long time there. And the sysadmin practices, a lot of them are still the same that they have been since like the 70s, right? Where you're logging into a machine and you're manually changing these things. And so that side really needs to catch up. We really need to try to get some of the value that has been happening in these spaces of development and improved delivery. So, and you think there's been a few mentions of the Puppet Labs DevOps survey that we sent out a while ago to sort of see what the state of infrastructure is, and the numbers are terrible. It's taking forever to deploy things. Every manager somewhere is complaining about the fact that ops is too slow, IT is too slow. It's taking me weeks to months to get a server. When I have a change request that needs to go into something, it takes my team forever to push it through because they're afraid that something's going to break. Most people who are working in operations spend most of their time doing really routine stuff. They're responding to alerts all the time. They're logging in and making changes, and they're doing the same sorts of things over and over and over again, even if they have built some kind of automation in there. And of course, lastly, actually understanding what's going on in your infrastructure. People write all the best scripts in the world. You can have all kinds of really quick automation in there, but you really still need to have some way of understanding what happened, when did things get changed. And so commonly, the solution to this is, well, before I change something, I'll just open up a ticket that says that I changed something, and then somebody will approve that change, and then I'll go and do the change. And you're sort of just adding these extra manual steps of, hey, you must document this. And the only thing that's actually really enforcing tracking that in that sort of change pipeline is the fact that you're going to lose your job if you don't do it. And we're humans. We're going to make mistakes. We're going to forget to open a change ticket, or we're going to make that, just that one tiny little thing because it's super quick. Just let me log in as root and do it. So in terms of the automation, these attempts to work on solving these problems, obviously manual configuration doesn't work. Golden images is a really popular one. You need to get systems out and deploy really fast, but we end up drifting tremendously. How many people here have used something like virtual machine templates to do all of their deployments, or DDing a disk and then copying that disk image out to all of your servers when you try to run it, right? It seems really cool at first. I can manually set up the machine the way that I want to just once and then just copy that exact machine state and put that everywhere else until you need to change something. And then you're going to change it in your golden image, maybe, or you're going to write a script that logs into every single machine and tweaks that little change so that it's set up the right way. And then, so maybe you get them changed out there. Maybe your script is going to work consistently everywhere that your script is supposed to work consistently, because that happens every single time, I'm sure. And maybe you're going to get all of those things done, and you're going to do that every single time. In that case, maybe golden images wouldn't be so bad if you could actually be sure that every single change you were tracking was the way that it was supposed to happen, and that your infrastructure is not just some big crazy pile of drift, and that you're not going to log into a system sometime or deploy an application sometime and find out, oh, this is the thing that's from last month that doesn't have that fix that we put in last week because of this problem. And so you don't know. So the tools that we have or had just don't really work. We need something better. So Puppet, the idea here is something to sort of solve all of these problems. Puppet was created back in 2005 by Luke Kanies, who was basically sick and tired of the current state of infrastructure and configuration management. He'd worked at a few different companies and tried to use a lot of tools and found that nobody wanted to use the things that they were currently using. The solutions that existed were completely insufficient, or they were really good solutions, but just really, really hard to use. So Puppet was made to help solve these problems elegantly and easily. So we have a large growing community. We have a tremendous amount of users. I don't know if any of you, just last night we had a users group meeting here in New York City. It was great. It was a lot of fun. I recommend you check that out. Large customer base. We just this morning announced an additional round of capital from all of our same additional investors to hopefully continue to grow extremely fast, which we have been. So overall, like fairly somewhat established mid-level startup company. The fact that you've all heard of it is good news to me, I think. So what's the actual philosophy here? What is it that makes Puppets as software different from everything else? So in these script-based approaches that people generally take to solve automation, you're applying a sequence of steps. You are executing, I want to do this thing, and then I want to do that thing, and then do that thing, and hoping that somehow ends up in the machine being the way that it is. As a sysadmin, we're so used to using like Bash or PowerShell scripts that we always tend to think of this stuff in terms of, well, what do I do to solve this problem? Not what should the end result be. So Puppet starts from the end result. We have a declarative language that describes what the state of the system is supposed to be, and then an agent will periodically run and always enforce that state. So it doesn't matter if the machine is brand new and completely blank, or if the machine's been running for a long time and you recently made a change, Puppet will always converge that back to that original state. Okay, so we start with some desired state. We want the home directory set a certain way. We want this user to exist or this package to be installed. Puppet, the machine will drift or it won't be configured correctly, and Puppet will always just correct back to the way that it's supposed to go. Okay, so infrastructure-wise, we have a set of agents that get installed on every machine that's being configured. At the master node, you have all of these configuration state defined. So the agent will periodically check in with the master and send up some basic data about itself that says, well, this is my host name, this is my operating system, my IP address, information that's helpful to decide how am I going to be configured as a machine. The master then has all of your code that defines this is what my state looks like. And so combined with that information that we call facts, the host name and operating system and all that, the Puppet agent the Puppet master will build a catalog that describes that specific machine's configuration. Okay, so the catalog is not code really. It's just a description of the state. there's no data about any other machines. There's no conditional logic in it. Nothing about the catalog really is telling the agent machine to make a decision about what that target state should be. It doesn't read it and say, well, am I a web server? Okay, let me run the web server installation code. Or am I a database server? Let me run this database server installation code. It's just that one machine stateful configuration that's sent down. So the Puppet agent is going to take that assigned state and walk through and compare for every resource on the system, so files, packages, services, and say, do I match this defined state? If the agent finds that the resource that it's currently evaluating matches the state, it moves on to the next one. Everything's good. If it doesn't, it will change it. So if the package is not installed, or if it's installed at the wrong version, or if the file configuration isn't set correctly, Puppet will update those things and note all of that in a report. So the report's going to contain every resource, additional details about the run, but every resource that Puppet was supposed to be managing, and say exactly what the state of it was before the run and what changed during the run. And so we have a full detail of everything about that node at the time that run happened. And then, of course, that report can go off to any kind of third-party integration or anything like that. Places where you can actually collect this data and analyze it and do metrics on it. It's very pluggable. So what is this resource thing in Puppet? Essentially, we have a file or a package or something like that, and Puppet models it in a way where it lays out certain properties of that file. Here's a screenshot from running the Puppet resource command, which is a tool to just examine your system in the same sense that the Puppet agent will actually examine your system, looking at my httpd.conf file. And we see, it's a file, it has a certain content set, it has these permissions, it has this mode. All of these details are exposed as properties of that resource. So when you go on Puppet and you try to set something, you just say what you want these properties to be, and then Puppet, through a series of programs called types and providers, understands how to check the status of that resource and then change it if necessary. So this is also platform agnostic. I could run these same commands, although maybe the paths would have to change a little bit on any platform that Puppet supports. So I can check things like service status or files very easily on both Linux, Windows, AIX, Solaris, what have you. And Puppet, because these providers are written individually for the separate platforms, but the types are agnostic, is able to work across these different systems very easily. So here's an example of actual Puppet code written. This is sort of a way that you might define a service account for a system. I care that this user exists. I care that it has certain settings for the UID in the group, and that it has a certain home directory set. And this doesn't really look like programming for the most part. You could pass this off as almost documentation, right? We take a collection of these resources and we put them together in what we call a class, and we say, look, this is what an Apache server is supposed to look like. Granted, simplified example, but this is what an Apache server is supposed to look like. We're supposed to have this package installed and this file set and configured in a certain way, and you can give this to anybody and say, yeah, that's what my server looks like. Okay, it's executable documentation. This is not a sequence of instructions that's telling something what to do, that relies heavily on what the current state of the system is. And so as you're constantly releasing changes to your machine, you can be confident about what the state is and not just the steps were run. Okay? So we take these classes and we take these classes which are composed of resources, and we take these classes and we can then assign them to different systems. So I can say this is the way that Apache is supposed to look, and set up Apache to be configured a certain way, and then map that out to multiple servers. So I don't need to write the same Apache code over and over and over again, or say this server gets this configuration, this server also gets this configuration, and write out all the details. So I build these classes into modules and assign the modules to different systems. And whenever I need to make a change to something, I can change it in just one place for that application or for that functionality, and it's automatically applied out to the rest of my infrastructure. So again, all of this is code. That's really the best part, and that's why it's particularly relevant to an audience like this, is that we've defined this entire infrastructure as code, which means that all of the advantages of code can be applied to our infrastructure. We now have environment versions that we can do, right? This is version 1 of the production infrastructure. This is version 2 of the production infrastructure, changed last month at exactly this time. And all of that goes into your version control. And this is something that the operations team can really get behind, because we know exactly where we're running and what's going on. We know exactly what was changed and when and by who and why, because you're writing good commit messages, right? all of these changes can be made in small chunks, okay? It's easy to tell what the entirety of a change is. I say this is the change that I'm making to my Apache system, and that's all that you see. It has nothing to do with the rest of the running state of the system. You've just changed what that target state is supposed to look like. And of course, we can easily go back if something goes wrong. If for some reason this small discrete change that we made broke something, I can just revert back to the original one in my Git repository. And because we're describing a state and not describing a sequence of steps to get from state to state, Puppet knows how to figure out the path back. All you have to do is revert your change. Okay? So again, now that we finally get into it, we have this all as infrastructure as code. We can put the Puppet code into a build pipeline, and some people were kind enough to describe some instances of doing this. I mean, this is really valuable to the infrastructure team. Everybody sees how helpful it is for the development team to push all of their artifacts through a CD pipeline, have them thoroughly tested, be able to release them very, very quickly to try to get feedback. But now you can do the same thing with your infrastructure, and you can see, does this work really well? I can tell from my performance monitoring if the change that I just made has increased disk queue lengths on my secondary database server, all very easily. And I can track all of that and see exactly what's happening. So that feedback loop is there in operations now too. It's no longer, well, Joe logged in and made a change last week, and things have been a little funky today. I'm not really sure why. It's all right there. You can see exactly what it is. And of course, this also means that you can thoroughly test it. So everything about your infrastructure and the changes you're going to make, you can test to see that they've actually been made. And there was, I think Kasuke mentioned server spec before, is a way that you can check that system status. We can recreate this configuration definition and make sure that it's actually set the way that it's supposed to be, and we ultimately can reduce outages. I think the last time we saw data on it, something like 80% of all outages were caused by misconfiguration or configuration errors, right? I mean, how often have you gone to deploy something and find that 4 out of 5 servers have the right configuration and the last one doesn't? Anybody remember Night Capital? These things go bad, and configuration is a major, major pain point. So of this Puppet code, you want to test it, right? And this testing is what gives us all of this reliability. And Kasuke also mentioned RSpec Puppet earlier. This is a Ruby RSpec-based tool that will take that Puppet catalog, that configuration definition, and check to see that it says the definitions you expect it should. So you can throw these Puppet tests into your pipeline, or your infrastructure or compliance team can throw these into a pipeline and make sure that the Puppet code that's getting produced meets certain standards, or that the logic that you have in your Puppet code is actually coming to the correct result that you want. We haven't actually changed anything on the server with this. We're just checking to see that the definition we're stating is the definition we really expected to be stated. And the beauty of these is that these tests run really fast. We just compile a catalog, look at the catalog, make sure that everything seems about right. It's not very difficult to do. No changes are made anywhere. We just build out that configuration and say, is this the right end state to get to? The next step along that, though, is we really need to actually try these things out. We need to say, okay, so yeah, we've got the right configuration defined, but Puppet is software, and software is usually always perfect. Things rarely actually go wrong, especially not with Puppet. So we need to actually take this Puppet code, build that catalog, apply it to something, and then make sure it still did what we expected it to do. We need to make sure that I didn't mistype the URL for my Yum repository, or that an Apache configuration option that I'm setting and that RSpec said that I'm setting correctly doesn't have some kind of a typo in it, that all these things are really the way that they're supposed to be. And so Puppet Labs created this framework called Beaker, which allows you to easily, automatically, on a huge number of virtualization platforms, spin up test machines, build Puppet catalogs specific to those machines, and then run server spec tests against them to say, is this actually the correct state for this machine? Is it the way that it's supposed to be? And right now, I mean, originally supported just Vagrant and vSphere, but now almost any popular public cloud imaginable has support for it. OpenStack, AWS, GCE, all kinds of stuff. So all of these are things that go into your test pipeline, right? So the, where'd I go? Oh, that's wrong. So we have this extreme reliability, right, on these tests. We know that we can set up RSpec tests to check the settings very quickly, and we can reject changes very fast when there's silly logic errors. We have Beaker tests that run after that take much longer, and those actually test to see that, make sure that everything works correctly. And so we have this tremendous stability in our code. And that combined with the fact that we can reproduce an environment at any time means that our developers can now take that Puppet code and apply that on their own. They can have their own Vagrant environments or their own personal virtual machine somewhere, and they can take exactly the code that your operations team is running in production to set that infrastructure up and set up their own infrastructure. And that's the piece that they test their code against. So you don't run into a situation again where they've been testing against something forever that 2 months ago was the status in production, but ops just pushed a change last weekend right before the release, and that broke everything, and we didn't even realize it. And we never caught it in QA because the changes are different, right? We have that same defined state, so that same infrastructure goes everywhere. And this was alluded to in a few talks before as well. So since operations and development are both running that same infrastructure, and we see that there's this dependency to this, now we can also put them together on the same pipeline. And this encourages that configuration. So you put your your infrastructure code sort of at the beginning, that in a way that will feed into the application pipeline. So your developers can keep doing what they're doing sort of at the front of this whole thing. And then whenever an infrastructure change happens, that has to go through and will not pass until the application code passes on that as well. So now instead of testing just your application code somewhere in isolation and manually fixing your infrastructure or setting whatever settings, you're testing them both in combination. And you can be sure that this code for this infrastructure, that's my release. It's no longer just, well, that's my code and hopefully this will run on the infrastructure somewhere. The infrastructure plus the app really is the product. Especially if you're running some kind of a service. Maybe not as much for a standalone, non-internet accessible mobile app, but I mean, really, who's running something like that anymore, right? The infrastructure is critical. The application is critical. It's the combination of the two that makes this valuable. And so you put them together in the same pipeline, and now your development and your operations teams are focused together on the same shared goal, and nobody wants to break the build. So ultimately, to summarize this, you have Puppet declaring the state of your infrastructure in code. You are version controlling your Puppet code. So you have that history. You see everything that's happening. You are testing and deploying your Puppet code in tandem with your app code, using RSpec Puppet, using Beaker to do these tests. And you now have the reliability from infrastructure, and you have that your reliability added to infrastructure, and you have that business alignment where everybody's finally on the same page, and there's that D something S word, I forget what it is. So DevOps, that was it. So some additional reading, just puppetlabs.com/learn. It's the best place to get started if you really want to start learning how to use Puppet and work with that. We have RSpec Puppet is the spec testing framework that I discussed, and Beaker is the integration testing framework, or acceptance, or functional, or whatever you want to call it. So one piece that I mentioned earlier in this that's really important is that reporting, and I sort of glossed over the fact that Puppet is generating metrics on all of this. All of these changes that are happening are being sent somewhere. So it's great to log what your configuration state ideally is supposed to be. It's another thing entirely to know if that ideal state has actually been correctly applied. So it's Puppet's job to go out and do that, but again, Puppet is software, and software makes assumptions, and software breaks. So you need a way to actually see these things and make sure that they're actually applying what you expect them to. So I'm just going to quickly run through a quick demo of some of the display that we have or some of the reporting capabilities that we have in Puppet Enterprise. So this is the Puppet Enterprise console. Now, Puppet is open source software. The vast majority of it is just combinations of these open source pieces put together. Puppet Enterprise adds some extra value around that and automatically configuring things and automatically setting up things like this dashboard that are going to show you what those agent states are. So here I have 2 agents. Nothing's really changed on them. I actually blasted the reports before I came up here. I can click into any one of these and see exactly what the settings on them are if I'm logged in. Live demos always go smoothly, by the way. So on this agent, I can see the status of what happened in previous runs. Like I can look at this last one and see the full log output of it. I can look at this and see what the events are and what happened with that agent as I was working with it. And really nothing changed. There's a number of resources that I'm managing, but they're all in that correctly defined state. My code says that this setting needs to be set that way, and it was. So nothing had to be modified on that agent. But what would happen if I logged into that agent? So I have the agent at the bottom and the master up here at the top. What if I logged into that agent and then changed something? So maybe my application, for instance. What happens if somebody breaks into my system and they delete that app. You know, I could have had scripts that say, okay, run this deployment. And whenever I want to run a deploy, it says, okay, there's my application. It's been deployed. Everything's hunky-dory. I'll see you again next release, right? You're not managing that state over time, so you could drift away from that configuration. It may not be as dramatic as the actual directory being deleted, but any number of changes could have happened here that would cause a problem. So if I go back on this agent, now that directory is gone, and a Puppet agent run happens, this again typically happens automatically. I'm just running it manually for purposes of demonstration. We see that the Puppet agent is going to examine this machine. It's choking on my laptop right now, but it's usually much quicker than that. And we see that, oh, we had this version control repository that needed to be deployed in that directory, and some junior admin or some jerk just logged in and deleted it when they shouldn't have. So Puppet has now recreated that. It sees, oh, that repository is not there, and it should have been. And if I look again now at my app directory, there it is. My file is back where it's supposed to be. My app has been safely redeployed. And the beauty of this, and the whole reason that I'm showing you, is because now I can go back to this console and see exactly what the history of that agent was. We now have a new report run. Each one of these reports, again, every 30 minutes is showing what changes happen on the system. We have a new one that said, oh, there's one changed resource here. If that one there, if that's not too small to see. And if I dig into this report, I can see exactly what changed on June 19th at 9:48 UTC, and that was that this VCS repo was recreated. Okay, so this gives us all of the information that we need to see that on a per machine basis, but additionally, we can try to find changes historically throughout our infrastructure. Say that it was much more complicated than, oh, well, I logged in and my web page was gone, you know, because some jerk deleted it. That's a pretty obvious one. What if it's something much smaller, like a configuration change happened somewhere in a middleware layer, and all of a sudden packets started dropping and you had no idea why, and you didn't even know where to look because your stack is so large and so complicated that you're not sure where the problem really was. So what changed? We can log into this event inspector, and this, I mean, not as impressive with 2 nodes managing like one resource with one change, but easily see based on our configuration classes, which are those compositions of resources that we talked about, by the nodes themselves or by the resources, which one of these had changes, and dig into them deeper. So it looks like one node had a change. Oh, that was my agent node. What changed about it? Oh, this VCS repo was redeployed this time. Very easy to click through and see that. Now this is a Puppet Enterprise graphical feature. The important thing about this is that all of this data is generated by Puppet during every run, and it's accessible through either a backend database or through somewhere wherever those reports can be sent. And that's a very extensible interface that you can write whatever you want to pull those out and process them, as long as you can figure out how to work with a YAML file. Okay, and I'm sure that most of you in this room can figure that out. So all this data is there. It's really helpful. It's really easy and accessible. And I think I have a little bit of time left for questions. So the question you're asking is if you're using golden images as your configuration method right now, is the approach to move from that to Puppet, to take the golden image, figure out what all of the resources are on that image, and then sort of copy it and then pass it on and redeploy that everywhere? So I would say probably not. Generally speaking, so Puppet is managing the things about your system that you have explicitly stated. And honestly, who knows what's in that golden image? Anything could have happened on that for all of the years that it was going through being manually changed and adjusted. And you want to start from the beginning with a fresh version controlled environment, right? So you could take that golden image that has all of these things on it, and since we're working in small chunks to expand our deployment, install the Puppet agent onto that golden image and have it manage something. And then have it manage something else, and then manage something else. And then eventually, as you build your stack up, you can move away from that golden image to a golden image that's really just a plain OS install that has nothing done to it except for, oh, this is the newest version of Windows 2012. I'm just going to install that as it is right now, then install the Puppet agent, and then everything else should be taken care of automatically. Right here? Can the Puppet agent heal itself? If you delete the Puppet agent, can it heal itself? No, because it's deleted. It doesn't exist anymore. So I mean, Puppet sort of is like that piece that's there. There is, however, at least with Puppet Enterprise, a separate tool that ships called mcollective, which is a separate daemon which could be used to fix Puppet if it breaks. mcollective is also an open source tool. It's just Puppet Enterprise bundles them together. Back there? Sorry, closer and then, okay. So, right, yeah. So the example I showed about the HTTPD configuration file, I think I actually showed a template there. Let me pull that slide back up. So you were talking about here, right? We have this content line defined for that HTTP configuration. So in this example, Puppet uses Ruby ERV templates. Those of you who don't know what those are, it's sort of just a very simple way. You take a regular flat configuration file or whatever type of file you're managing, and then cut out little pieces of it and replace them with a special syntax that says this value here is going to be variable. So I could take my HTTPD configuration and maybe say, well, the listening port's going to change from server to server. And so cover up that 80 with a little bit of very simple syntax, so that when Puppet runs with this template, it can actually fill in that port based on variables defined in your Puppet code. So I can have one template that sort of applies to the vast majority of my servers without having to rewrite it over and over and over again. Here? So one of the built-in resources in Puppet is a service. The question was, is this all about just the file system? Is it just changing things on the file? So the answer to that is Puppet can manage anything that we could write Ruby code that would be able to check the status of create, destroy, and modify. So these providers that we have in Puppet that are changing individual settings, or the pieces that know how to do that, it doesn't have to be something on the file. The file system is the most likely place to look because that's where most of the interesting configuration happens. But for instance, Puppet has a service resource that can check the status of a running service and make sure that that service is running or started or stopped or set to turn on at boot up, things like that. And that's a perfect example of one that works pretty much the same across all the platforms that Puppet supports. So it's not just the file system, it's anything about the state of the system that can be managed, could be managed. More questions? Back there? That does include the Windows-specific items. The only difference, at least on this slide, is on Windows. The Windows packaging is a little bit different. Windows is not quite caught up to the Linux world in terms of package management. There are tools like Chocolatey that are available to make that much, much easier. But you would just add some extra parameters to this to be able to install an MSI directly. Multiple configs for a single set of hosts. Well, what do you? Yeah, you can manage any file on the system, and if you can define that file, you can manage it through this logic. Are you asking if the same template can be applied to multiple systems with different values, or if you can have one system that has multiple templates applied on it? Yes, you would just need to create separate resources describing the files managed by that template. So I would have multiple file resources here saying, I've got my HTTPD template, I've got my SSHD template, and things like that. Any like sort of general high-level questions? Okay, well, thanks everybody. I'll be around for questions after.